One way of finding the derivative of the function is by first principles, that is, by using the definition of what a derivative is. Now we're going to apply this method to finding the derivative of the function y equals the square root of x. So we take a small change in x, delta x, and that allows us to write delta y over delta x equals the root of x plus delta x minus the root of x divided by delta x. Now let's multiply both numerator and denominator by the following. We've got root delta x plus root x divided by root x plus delta x plus delta x. Now what this will do is it will actually simplify the expression quite a lot, because when we apply this we get the following. The numerator simply becomes delta x. Try multiplying it out and you'll find that's correct. We get on the denominator delta x multiplied by root x plus delta x plus root x. We can divide both numerator and denominator by delta x and write this as 1 over the root of x plus delta x plus delta x. Now, from first principles, we define the derivative as dy dx is the standard part of delta y over delta x. Remember, we're treating delta x here as being an infinitesimal increment. So this becomes 1 over the standard part of root x plus delta x plus root x. And of course the delta x simply disappears here and we get 1 over 2 root x. And that gives us the derivative by first principles of the function. Now in practice it becomes quite tedious to do this for all types of functions, so instead we apply a set of rules, and here we're going to apply it to the following functions. Let's first of all take the derivative of the function y equals 4x multiplied by x plus 1 squared. The easiest way to differentiate this is by using the product rule. We define two new functions, u equals 4x and v equals x plus 1 squared, and those give us derivatives du dx equals 4 and dv dx equals 2 multiplied by x plus 1. Now we can apply the standard product rule and we get dy dx equals 4x u multiplied by dv dx, so that's multiplied by 2 times x plus 1, plus v, so that's x plus 1 squared multiplied by du dx, i.e. 4, and if we multiply that out we'll get 8x multiplied by x plus 1 plus 4 multiplied by x plus 1 squared. So that's quite a simple way of finding the derivative. Now let's look at an example of using the quotient rule. Here we've got y equals 3x minus 1 divided by x plus 2 squared. So again we're going to define two new functions, u equals 3x minus 1 and v equals x plus 2 squared. So y equals u over v. So we've got du dx is equal to 3 and dv dx is equal to 2 multiplied by x plus 2. Now we can use the standard quotient rule formula. Dy dx is equal to v du dx minus u dv dx divided by v squared. And we've got all the information we need to calculate this. So we can write this as v, so that's x plus 2 squared, multiplied by 3, minus u, so that's 3x minus 1, multiplied by dv dx, so that's 2x plus 2, and then divide that by x plus 2 squared all squared, so that's x plus 2 to the power 4. Now we can simplify that quite a bit by cancelling and write this as 3 over x plus 2 squared minus 2 multiplied by 3x minus 1 divided by x plus 2 cubed. Okay, now let's look at an example of using the chain rule. We've got the function here y equals root of 4x squared plus 2x. Again, we can define u equals 4x squared plus 2x and write y equals u to the power of half. Du dx, or sorry, dy du is very easy to calculate. It's just a half u to the minus a half. And du dx is also very easy to calculate. That's equal to 8x plus 2. Dy dx is just going to be the product of these two derivatives. So we write dy dx is equal to a half of 4x squared plus 2x to the power minus a half multiplied by 8x plus 2. And again, we can simplify this a bit and we can write this as 4x plus 1 dividing through by 2 divided by the square root of 4x squared plus 2x. Now let's take a look at one final example, which is an application of the power function rule. We've got y equals root x here to the power 4 over 5. Now we could use the chain rule here, but it's actually simpler to just multiply this out and use the standard power function rule. So we can write the function as y equals x to the power 2 over 5, and the derivative of that is actually very straightforward. It's just dy dx equals 2 over 5 multiplied by x to the power minus 3